So classification of computers. So we'll see how we can classify computers according to their maybe the size, maybe their usages and the technology. So let's proceed. We can classify computers according to their function, size and processing powers, and the type of data handled. This is very important. Let's dive deep. Computer classification factors. So we can use the size, function, and type of data handled. So here you have a quick overview. When it comes to size, you have supercomputers, mainframe computers, mini computers, and microcomputers. And by purpose, we have general computers, general purpose computers, and special purpose computers. When it comes to type or the data handled, we have analog computers, digital, and we have a combination of analog and digital. We call it as the hybrid. It's like the hybrid vehicle. Based on size, it's obvious. So here we have some personal computers. We can call them as microcomputers. It's handleable, it's compacted. Laptop is also microcomputer, and there's a small version of laptop called the palm top. Palm top, you can keep it on your palm. Smaller version of the computer. And the mobile devices, we can call them as mini computers, microcomputers. And we have mainframe computers, where you can find mainframe computers in banks and other organizations. There you have something like this. So they have a centralized server, a little server, and for that server they have connected several keyboards and displays. But if you carefully see, you don't see that system unit there. When you follow the cables, all those cables, maybe 4, maybe 8, all those cables are connected to a centralized system unit, right? So these are mainframe computers. And most importantly, we have supercomputers. So these are special computers mostly used for scientific calculations and handling millions, trillions of data, right? In the real life, it's hard to see supercomputer. Then let me go again to this classification. We have supercomputers, we have mainframe computers, and we have mini computers. And here we have some microcomputers. Imagine about your smartwatch. So it's a portable computer. Imagine about your Android or iOS phone. It's a portable one, right? So that's the classification based on size, physical size. Supercomputers. More about supercomputers. They need extreme amount of capacity. Maybe it's large like this total lab, and they have greater speed, contains multiple CPUs, and they can be operated parallelly. So when it comes to a problem, one CPU is developing the problem solution and other one is parallelly working face to face. Runs tens of millions instructions per second. An operation is made up of numerous instructions. So they will use numerous instructions to operate, and operating such is not an easy task. It's expensive, and because it's large in size, and also they consume large energy. And here you have some examples. So quantum physics, they are using scientific or these types of computers, weather forecasting, climate research, molecular modeling, physical simulations, here aircraft and spacecraft designing, nuclear weapon testing, encrypting, decrypting, and in data warehouse. So there's something called data warehousing. So there also you have, and here you have some examples: IBM, Deep Blue, and Fujitsu's K Compute in Japan, IBM's Mira in USA, Supermuse in Germany, likewise, and the mainframe computers. When it comes to mainframe, as I mentioned, it's smaller than the scientific computers, but still it's large and it can perform large calculations. So it is the second largest computer in the computer family. So here, as I mentioned previously, used in large organizations such as insurance companies and banks, where many people frequently need to use the same data. So several desktops, the mouses and keyboards are connected to a centralized mainframe, and there you can use it. Allows its user to maintain large information storage at a centralized location and able to access and process the data from different computers located in different locations. Imagine about the head office. When you update something inside your branch, the head office admin staff can access this still. Each user access mainframe's resources through a device called terminal. Right? So the mainframe interfaces are called terminal. Terminals in the sense a keyboard and a separate mouse and a desktop. Two kinds of terminals are available: dumb terminal and intelligent terminal. Dumb terminal, it's just a input output device, right? Maybe a touch screen, maybe a window to a computer located somewhere. And what is about the intelligent terminal? It can perform some processing, and but it does not have a storage, right? Imagine the bank computer, it's a intelligent terminal, right? But imagine about a dumb terminal, touch screen located at the parking lot. When you just press a button or something, you can get a ticket for your vehicle, but other than that you can do any processing. Mainframe computers are often household along in special rooms away from their users. It's true. It's for security purpose, maintenance, accessibility. IBM 370, S390, VAX 8000, CDC 6600. Then you have mini computers, medium in size, mini, right? Like the Mini Cooper, right? Able to process and store less data than a mainframe computer, but more than a microcomputer, right? So scientific computers, mainframe, mini and micro, four families, right? Known as mid-range computers. So it's average, medium. Capability of microcomputer is less than the capability of mini computers. Mini computers capability is less than the mainframe computers. Ascending order, and here we have the scientific computer as well. These computers are usually designed to serve multiple users simultaneously. It is capable of supporting 4 to about 200 simultaneous users. They are more expensive than microcomputers. Examples: here you have Digital Alpha, Sun Ultra. Then the last types of computers, last main type of computers: scientific, mainframe, mini and micro. Micro, the smallest and low cost, like my laptop, single user and general purpose. The older PC starts 8-bit processor with speed 3.7, and current PC 64-bit processors with speed up to 66 gigabyte. Examples: IBM PC, and here it has Pentium microprocessors, Apple Macintosh. They consist of CPU, input unit, output unit, storage unit, and the softwares, microcomputer. These are standalone machines. They can be connected together to create a network of computers, like here we have in this lab. Can be classified into two types: desktop and portable. The difference is portable can be carried, can be used while traveling, but desktop doesn't. And more about portable computers: laptops, notebooks, palm tops, wearable computers. We call them as portable, and wearable computers. And the laptop under which category is it? It's under the micro computers, right? Portable and have all the features, expensive than desktop. Why is that? It's integrated. You have a inbuilt battery, camera, touchpad, keyboard, but in desktop it's separate. Smaller in size, can be carried anywhere, has battery backup, functions of the desktop, same as the desktop. And the notebook, so it's a little bit smaller than the laptop.
Laptop is different work.
Yes, it's different than yes.
Portable.
Yes, laptop is a portable computer and it's portable than desktop. Desktop, you should carry the system in it separately, the UPS battery separately, then other um, displays and keyboard separately. But in a laptop,
Someone PC, name by PC.
yes, there are many naming conventions according to the computer manufacturer, but overall the laptops has the overall almost all the laptops are same. They have a screen, they have the touchpad here and the keyboard. But yes, so when it comes to this laptop, we called it as Dell, but actually Dell has desktop computers as well. So yes, they have named laptops according to their desktop names. But here we have some different model names. So this is Inspire series. Then we have Dell Latitude series, likewise, right? So when it comes to HP, there you have HP notebooks and stuff, right? And there are some other companies that they only produce laptops. I think the ThinkPad, there's a ThinkPad laptop. I think they don't produce desktop, right?
Lenovo.
Yes, Lenovo. They are all desktop computers, but they are most famous for their laptops, laptop production. Lenovo ThinkPad. And notebook. So the main difference I have observed in notebooks are they don't have a CD-ROM or the CD reader, right? So that's the main difference I have witnessed. Anyway, it's smaller than the laptop, right? Laptop. So the notebook is bigger than this one. The laptop is bigger than a notebook. And we have the palm top, as I mentioned. So it is a very little cute little computer, right? And wearable computers. So you have some medical devices, you have some trackers, you have some digital watches, right? The insulin meter, pacemaker, and digital watches, right? Likewise, and maybe the smart glasses like the Google Glass, and the Ray-Ban spectacle band has already released a new Ray-Ban smart glass. Classification based on type and data. So we have finished about the classification of the size. We have finished it, right? Size finished, right? So just to do a summary: scientific computers, mainframe, mini, and micro, right? And classification based on type of data handled. So what about the data types? So here we have the analog computers and digital computers. This is like this. Imagine about a petrol pump in a fuel station. Petrol pump. It itself is a computer. Why is that? Because when you pump petrol, it will calculate the number of liters dispensed and it will calculate the amount there, and the liters amount and the charge you need to pay. It itself is a computer. But the thing is, there you have some physical actuators. So the petrol pump, the computer system there will measure the flow speed, the flow speed of the petrol liquid using a propeller like thing, right? So when the propeller or the thing is rotating, it will measure the rounds and it will do a calculation, and that's how the dispenser calculates the amount or the volume of petrol, right? Now forget about it. Think about a speedometer of a vehicle. how a speedometer works. So the conventional speedometer will use the cable to rotate, and when it is rotating, it's going to rotate some other gears, and that's how that hand will rotate in your speedometer. Now these days smart speedometers have sensors, and it will rotate the number of it will evaluate the number of rounds, and that's how they are using, right? Right. So that's about the analog computers, right? Then what about the digital computers? So imagine these things. So here I'm going to press a button. So I'm going to open the calculator here, and I'm going to press 8 minus 5 and press enter. Now the answer is there are 3, right? So here, are they going to measure physical things? Are they going to measure physical things? No, right? They are not going to measure physical things here. So that's the difference between the analog computers and digital computers. So digital computers,
Electrical.
yes, digital computers, they solely depend on digital signals. So what are the two types of digital signals? Two types of means the two status, 1 and 0, on and off. But here, when it comes to analog computers, they will maybe measure the speed, right? Maybe the temperature, right? Yes, voltage, likewise, so much physical things, right? So that's the difference between the analog computers and the digital computers. Now, what about the hybrid computers? Now you can guess. They will calculate both, right? So imagine about a hybrid vehicle. Hybrid vehicle. So hybrid vehicles, you have both the engine, the physical fuel-fed engine, and the uh, EV, the electric motor, which use the battery power, right? So imagine a speedometer or some meters in this one. It should check the temperature of this physical engine, and also the temperature and other things in this battery also. So in that case, it's hybrid. It's hybrid because it should measure the physical things like the uh, oil pressure, oil temperature, and other things. And at the same time, it should measure the voltage of the battery, whether it's charging or not. Likewise, it should diagnose. So I think you got my point, right? Any problems? Right. So let's continue. Digital computers, right? So here we have examples, right? So I just give my own example. Work with numeric or digital form. Process data including text, sounds, graphics, and video into digital value in ones and zeros. Analog data converted to digital data. So now through this microphone I am speaking. So it will detect it, amplify it, and it's turning it to a digital signal. That's how the things are going to be recorded here in the software. Otherwise can't. Otherwise no way of holding my voice. If analog output is desired, the digital output has to be converted into an analog quantity. So it means like this. So imagine I have built a software to remote control the AC. So here there you have motors or actuators to turn on and off those flaps, right? So when I press the on button here, it will send a signal there, and it will convert into a analog signal, and that's how the AC is going to work. So imagine the press of the AC remote. So I'm pointing it there and pressing the off button. So how does it work? There's no any physical connection. It will send the signal there. It's going to tell the motor please shut off, and it's going to shut down, right? The components which perform these conversions are the essential parts of the peripherals of the digital computer. So you have some other supporting devices. Digital computers can give the results with more accuracy. Examples: desktop, laptop, cash registers, smartphones. Now the analog computer operates on data in the form of continuously variable physical quantities such as electrical potential, fluid pressure, mechanical motion. Likewise, do not deal directly with the numbers, right? Do not deal directly with the numbers. They measure continuous physical magnitudes, temperature, pressure, and voltage, which are analogous to the numbers under consideration. As an example, petrol pump. That's the same example I have. It will measure two things: quantity of petrol and the price. Analog computer used for scientific and engineering purposes, they give approximate results, not 100% accurate results. They are very fast in operations. Otherwise, you should wait 1 hour, 2 hour, maybe 2 days to uh, calculate the cost of petrol you have pumped. Easy to get graphical results directly. It's true, right? Now, in the LCD display on the petrol pump, you can see how much you have pumped. Accuracy of analog computer is less. So think about the petrol computer. Can you pump 0.5 millimeters there? No. All the analog computers are special purpose computers. You can't measure some other thing using a petrol pump. Examples: speedometer. Here you have a thing called seismometer and gasoline pump, right? So you can just Google it and see whether what's right. So then the hybrid computer has the features of both analog and digital computers. They are used for computational purpose, and for storage mostly they use digital storage. It's hard disk, pen drives, likewise. Have the ability to accept the input data either analog or digital form. Used in scientific applications, various fields in engineering, testing, diagnosing, likewise. So then the classification based on the function, right? So that's the end of the computer classification according to the data handling. Now the last part, according to the function. What's the function? It's easy. We have general purpose computers and we have special purpose computers, general and special purpose. What are special purpose computers? Think about the scientific computers. So designed only to meet the requirements of a particular task or application. So imagine the diabetic meter. So you can't test any other value using that one. So it's a special thing. The instructions needed to perform a particular task are permanently stored into the internal memory so that it can perform the given task only. They cannot be used for other applications unless their circuits are redesigned. So here these ACs or these air conditions are not made for heating purposes. They are just there for cooling purpose. Then you can't use it as a heater. But there are dual purposes ACs. So you can use them for heating purpose as well. But here this is a special purpose one. Special purpose computers are used for airline reservation, satellite tracking, air traffic control, and maybe the attendance marking. So there's attendance marking system here. You can only place your thumb there and mark your attendance. Otherwise, you can watch like this, and until it recognizes your face, and it will mark only attendance. You can't do anything other than that. ATM machines, washing machines, cash registers, and the general purpose computers, like the things like this laptop. General purpose computers are designed to meet the needs of many different applications. In these computers, the instructions need to perform a particular task are wired permanently into the internal memory, but one job is over, you can perform other job. They are versatile and generally lack in speed and efficiency. That's a problem, right? You can't render a 5-hour video clip using this laptop. It will overheat and it will crash. You can't run the latest version of Premiere Pro here. The computers used in schools and general purpose computers, desktops, laptops. Now we have come to an end. Summary: classification of computers. First, we have classified them according to the size. We have microcomputers, mini computers, mainframe, and supercomputers. Starting from here to here, the size is gradually descending. And microcomputers, we have desktop and portable, laptop, notepad, palm top, and wearable. When it comes to the computers classification under the purpose, we have special purpose and general purpose. Special purpose mostly scientific, washing machines, some other special application applicable computers. And general purpose, the computers we are using in the real life, we use laptops and other desktop computers. They are general purpose computers. And types of data handled, we have three types. The digital computers, so the laptop, desktop, they are digital computers and it's accurate and it only works with the ones and zeros. Analog computers, the most popular example is the petrol pump. Please explore more examples, right? And we have hybrid computers, something in between these two things. It will accept both the analog signals and the digital signals.
Calculated analog computer.
Um, calculator, we can take it as a digital one because it's similar to the calculator on the laptop, right? So you can't give sound input there or other input there.
Digital.
Calculator, we can take it as the digital one, can't take it as analog. So there were analog computers. So the website I have shown, there were analog computers. So let me show you, right? So that's the end of this one. So we have done the classifications of computers under three parts: type of data handled, sizes, and the function or the purpose.